Okay, we'll get started as it's nearly 5 past. This slot is kind of early in the US, so we tend not to have that many people join. We're doing one slot kind of early US time to accommodate people in Europe, more on later on alternate months. We're recording this and we'll post the link later. We tend to find that quite a few people watch these sessions later on. So today, we're lucky to have Hans Ecker here, who will give a demonstration of a Sift container registry that implements the library protocol, and that's open source, available on GitHub. We also have then an update on SingularityCE, so I'll go over what was in the recent releases and how we're getting on towards 3.9, and Adam will give an update on Sift v2 and how that's now being used. So without further ado, we'll hand it over to Heinz. So Heinz, you're able to share the screen or start talking to us now. I look forward to seeing what you have.
Just a second, I will try to, here. So I guess you see my screen now?
Yes.
Yeah, that's good.
Yes. So, okay, but I will maybe just start off with some background. So my day job is working at the Vienna Biocenter in the sequencing core facility. We do next generation sequencing, and I'm a bioinformatician there. And so we need a solution to organize and distribute our containers that runs on premise. And we were using S-registry for quite a while, but after the update to Singularity 3, we wanted to use the library protocol, and there was the short period where S-registry did not support the library protocol, but only the Singularity hub. So I don't know, I just started looking into it, and I found the library protocol was really simple and easy. So I just started reverse engineering and was looking in the source code. And actually after 2 days, I had my first working pull and push. So ever since then, we are using our own kind of container registry for Singularity. Everything, so this was about 2 years ago. Everything else that has been added is sort of, nice to have, but the goal was always to have some simple solution that works for us. So as far as I'm aware, I published it on GitHub, but no one else is using it. At least no one else told me that you are using it. So it's also not very battle tested, but I can just present what we have. Okay, so I will maybe just start showing off the web interface, which is, as you would expect, with login. By the way, I'm just showing my local here, my development instance, not our production instance, so that I don't accidentally leak some personal information from our users. But I hope everything works on my development thing also. What I did was put on top just some simple short usage instructions, how to add this as a remote and how to push and pull your containers. Then it shows also the expected things like the latest uploads and start containers that I personally have started. You can then, users can then see the collections, also create and do all the expected things like edit and also remove them. So there's the possibility to have public and private collections. Public collections every user can see, private collections only the user himself can see. Here are then the containers. Again, pretty much straightforward. You can make containers read-only. This means that you cannot push images to this container anymore, or tags, yes. Here is then the overview of the container itself, and you can also look at the Singularity definition file that was used to create this the tag. Also, it's possible to add tags and remove tags in the via the web interface. If there is so I have a field that is for Git or version control system. If this is set, then there is also a link to the Git repo that is used to create this container. Our continuous integration system automatically adds these links. The setup is also, I guess, pretty normal. Each user has their own entity with the username, where they can have where they can organize in collections, and yeah. Since this user is an admin user, I can see all the others too. There's this special collection that I called default. This is used if you specify only 2 parts of the library URL. So, for example, just for a brief explanation, this is the version that I compiled with HTTP only, so that doesn't require HTTPS. So let's just use. And oh, okay, that's just a key. Yep, so if there is only 2 parts in this library URL, it uses this default entity. This originally had this as compatibility to the Singularity Hub, which only used 2 parts of the URL, as far as I remember. It's based on tokens. Tokens can be created by users themselves. At the moment, a token can have an expiration date as well. At the moment, the tokens are stored on the database in ClearText, so you can also copy and paste them with from here, which is not best practice anymore. So the tokens should be hashed in the database and only displayed once upon creation, like it is standard practice nowadays. Since I'm an administrator, I can also show off the user administration. As you can see, there's only 2 levels of users. There are admins and non-admins. Users can be activated and deactivated, and can come from a local database or from an LDAP. The LDAP is connected to our general facility user database. One can create, of course, additional local users, edit users. When in the case of LDAP, basically you can only deactivate them. Email address and username and everything comes from the LDAP directory. I can also administrate tokens for users. The LDAP configuration is optional, but of course we use it. So there's just an admin interface, like I can ping the server and I can trigger a synchronization where all the users are transferred from LDAP to the local database. This is also run periodically. Here is also some maintenance tasks that are run periodically. So, for example, the LDAP synchronization is run every 10 minutes. Quota check and image expiration jobs are run once a day. So here you can just look at when the last run was done, and some information like here, 6 entities have been updated and the total space usage is currently 1.1 gigabyte. Of course, the quotas are updated every time someone pushes or deletes an image, but this is then some general householding that is done once a day. So, okay, there is so that the whole thing runs with Flask as an application server, and this also provides some basic CLI. So what I made some special commands just to add users and remove users from the command line. It's also possible to, for example, trigger the LDAP synchronization from the command line. Okay, so the Singularity library protocol, of course, works like you would expect. Let's maybe just do this first. And I can do, for example, also search. Yeah. The thing is with the key server here, I set up for my local development, I set up Hockey Puck, which is a normal HTTP key server. Since you use it seems like you just use the general PGP key server protocol. So this works fairly nicely. When you look at my our development, for example, I just pointed to a public PGP server, but we don't sign our images. So this is only for completeness sake. I did not completely 100% test this out, or that it works in every case. Okay. Lately, I've also been implementing auras. Mainly, I did this because I thought this could be a solution for some unsolved data distribution problems that we still have, like users uploading data or we providing data for our users. And then I thought I would also teach it auras. The nice thing is that once you have auras, you basically have an OCE conformant container registry. So this kind of really works very well. So I can also pull my Singularity containers as auras. And I can also use the auras client. So, and then I can do also, so and push. And since it's then already OCI conformant, I can also run this OCI conformance tests. I will not run them now, but now Hingscalia also passes the UCI distribution conformance tests, which I'm pretty happy about. Took a bit more than 2 days to get this to work because the in contrast to the library, the OCI is a bit more involved, and I think the standards are also not so clear, and there's a lot of how do you say, some things are up to interpretation, and when you use Docker or Podman, then they interpreted things a little bit different. So this was a bit yeah, not so easy. The whole thing is implemented in, okay, first maybe for short the data model. Data model is pretty straightforward. It's entity can have collections, can have containers. Then for Singularity, I made this link. Each container can have n images. Images are then connected to a file on the file system with the path attribute, and each image can have n tags. This is then for temporary for uploads, temporary, also for the chunked uploads. Once I started doing OCI, I had to introduce also manifests, and now tags can be also linked to manifests. So it complicated the data model also a little bit. The stack is pretty standard, I would say. I'm using Python 3 with Flask as application server and SQL Alchemy as object relation mapper. In the background, I'm running Postgres. The unit tests run with SQLite, so SQLite should also be fine. I'm using also Flask Rebar, which I think is really nice because you can have these marshmallow for serialization and deserialization of JSON. And you have very strict schemas that also validate the JSON. And the really nice part is that you can automatically get, Swagger Open API documentation for the whole API, together with examples like how do you create an entity, which fields are needed, and the return values are also documented, which I think is quite nice. For the background jobs, I'm using Redis queue with Redis server. So jobs are submitted to written to this Redis server, and where the worker processes are polling and executing the tasks and then writing back the results to the database. The front end is written in Vue.js, although I'm using TypeScript, and I'm using Node, but just to compile and build the front end. When you then distribute it, it's just a big bundle of JavaScript that contains all the style sheets, all the templates and everything. So for the operation, Node is not needed. It's served directly by the Flask server at the front end. Users, as I mentioned, we have a very shallow or simple permission system. There's just admin and users, and containers can be, or all the entities, collections, and so on can be public or private, but that's it. And we have a local database and LDAP. And for storage, I'm only support file system. So in our case, it's mapped to a network storage, but still it's just file system access. So I would call it rather feature poor. We don't have groups, teams, or organizations or anything like this, where you can share your containers only in a smaller setting. So it's either all or no one. There's no cloud backend, so it's not possible to store containers on AWS, for example. We don't have a remote build because we have a CI/CD pipeline that does this for us. So I push my container repo and it gets built and then pushed to the registry. I don't have anything like bandwidth limits. I don't even have xsend file support. So everything is handled by the Flask application server, which is maybe not the best from a performance point of view, but since we are not a big setup, it works for us. The only thing is that we might need sooner or later some single sign-on or federated identity integration. So maybe we will have to do some SAML or OAuth or OpenID, depending on whether we will get institute or campus-wide identity management sooner or later. And yeah, and the last thing that I mentioned also in the beginning is that it's rather untried, so I'm using it. We are using it. We have some users who are also on this, but in general, it's not very well tested. Yeah, that's it from my side.
Thanks very much for that overview. It's an extremely impressive project, and I'm sure people who see this later will be very interested and take a look. Are there any questions from those on the call at the moment?
I guess I've got one. So I know when I was originally looking through, kind of noticed your project and saw that you were patching Singularity. I think there was an issue created for that. I'm curious whether, you know, along those lines, I guess more generally though, whether there's anything, you know, SingularityCE could do to make it easier for, you know, you and your organization to leverage it, or whether that's been pretty smooth now.
Yeah. So the one thing is both auras and the library protocol, I think, require HTTPS. If there would be a switch to command line switch to switch this off, it would be awesome. But otherwise, I'm just always applying a very, very simple patch to my development version, and this works for me actually. And I think maybe it's good to not make it too easy for users to skip all the HTTPS SSL thing.
So I'll mention in a second when we look at the development work that's gone on that we've actually added a flag for adding a remote, which is HTTP, so you can pull the remote configuration from that. That's great. So I'll mention that when we look at the dev work in a second.
Yeah, otherwise I was pretty happy. I was also so I cannot program in Go, but I found that I could read the source code very easily. So it was also very easy for me to see what is going on and to implement everything. So yeah, no special wishes from my side.
That's great. Thanks.
Okay, we'll move on to the next bit now. We're coming out to halfway through. Let me share my screen, and what I want to do is just give a quick kind of report back on what was in the last two releases, which are close together. Then we'll look at what's been going on towards Singularity 3.9. So we released 3.8.2, SingularityCE 3.8.2 in August, and this was a bug fix release with numerous kind of relatively small but somewhat important bug fixes. Some of them, there's some cleanup on handling of some of the commands that talk to the library. Some fixes for bootstrapping for Arch Linux and Debian on non-AMD 64 systems. We had some reports from some users who were trying out workflows in GitHub Actions with ORAS around some kind of problems with handling token files and remotes. So those have been addressed. And we've got some fixes related to kind of escaping in the Docker files, translation of CMD and entry point. 3.8.3, which we released yesterday, was mainly kind of put out there so soon after 3.8.2 to get this fix out there. So there was a regression within the 3.8 series where if you source a file from the environment section in your def file, and that script that you're sourcing contains sort of shell built-in commands which have a backslash on them, so this is kind of quite an unusual thing, then it won't work properly. It'll report a file not found error. This becomes quite important because Anaconda environments, the profile scripts there actually have this kind of construct in them. So if you attempt to source from the environment, you get an error there. So we put out 3.8.3 yesterday with a fix for this, given that many people are using Anaconda, Miniconda in their containers. The 3.8.3 also includes a bunch of changes to dependencies to move us off of unmaintained versions as things change in the Go ecosystem, and does that via updating our Sift module to version 2, which Adam will talk about in a bit. I just want to highlight there isn't any change to functionality from that or the on-disk Sift format and so on. This doesn't change compatibility or anything like that. What I want to try and focus on a bit then today is talking about the things which are coming for 3.9. We've been lucky this month to be able to spend quite a bit of time on development work. So we have quite a long list of new features and sort of changed behaviors. We have a fix for a long-standing regression where labels in Docker and OCI images weren't inherited properly. This is actually brought in as a change kind of behavior for 3.9 rather than a bug fix, because there's technically a kind of issue that can arise if you're using labels in both a Docker source and a definition file where you need to kind of actually force overriding an already existing label. So there's a different behavior there because of this fix. So that's why it's in 3.9 and not included in a bug fix release. There's handling changed around copying files within container builds. We are switching to use Go's file path matching for globbing when you've got star wildcards, question marks and things in file names. And this is to get rid of some really rather inconsistent behavior where we were using a shell to do this previously. This is the these are kind of part of cleanup of the CLI, which has been ongoing. Down here, we're removing a flag which was only related to VMs and Singularity desktop on map. We're trying to also make flags more consistent as we move on. So the no HTTPS didn't have a dash, now it does, and so on. There's been quite a bit of work at looking where Singularity is using external binaries and making the finding of those binaries more consistent. So the idea is that the kind of key binaries that are used by Singularity and are relatively often substituted by people on their systems, i.e. there might be a system version, but they might install a module version on an HPC system or something in opt and so on. These can all now be paths to them can be set in the Singularity conf file. And when you build Singularity, it's going to find the binaries from path and then write them into the conf file. And you can kind of override that if you need. And if it's not set in the conf file, then it'll fall back to searching on the path. This is all about making the behavior a bit more consistent. Previously, things like MugsSquashFS and UnsquashFS, they were found in subtly different ways in different parts of the code. And it was quite difficult for people who had them installed in strange paths to kind of set up what they wanted to be used. The work here about NVIDIA Container CLI is quite a kind of big new feature. So historically, Singularity has used its own methods to set up GPUs in a container. We go out and we look at a list of libraries that are required for CUDA operation, and then we go and try and find those using ld-config, and we bind them into the container and make them available for use. Now, this works really well, but it doesn't support various things that people are used to with the NVIDIA Docker runtime, like being able to limit a container to only seeing certain devices, or being able to set environment variables that control exactly what's bound in, whether it's just compute libraries, or whether it's compute and display libraries, things like that. So we now have an NV CLI option, which will use the NVIDIA container CLI, which is kind of the official way of setting up a container to work with NVIDIA GPUs to actually perform all the binding and so on. This is an experimental option. We were hoping to kind of make this the default, but we've dropped back to having this as an experimental option because there are a few issues with NVIDIA container CLI that have arisen on some distributions like Debian 11, where there are occasional problems finding libraries. So we're going to expose this as experimental in 3.9 and look to move to it as a default method when these things are resolved. There's a few more notes there. You can now use writable tempfs during the test section of a build, so that if your tests need temporary space, it's available. We have a compat flag, which kind of turns on various other flags a bit more simply, that increase compatibility with Docker when you run containers. So that if you have a container which just doesn't work, that you got from Docker Hub and you tried it on Singularity, it doesn't work, the compat flag will enable a few options which give a good chance of working with Singularity. These are the changes which are relevant for Scala. So what we have now is no HTTPS, this flag, applying to connections made to a library service whenever you're using the library flag. So you can, if you're specifying a custom library on a pull or push command, you can choose to not use HTTPS and drop back to HTTP. If you have an installation of some kind of library and other services, you can also do a Singularity remote add with an insecure flag, and this will then look up the configuration of the remotes from the server over HTTP. It won't require HTTPS, and that allows you to set up a development install without certificates and easily start using it. I already talked about the NVIDIA container stuff in the previous section. The bottom one here, this is recently merged. We now have support for using C groups on C groups v2 systems, which use what's called the unified hierarchy for C groups. Singularity allows you to apply C group resource limits to a container when you run as root using a flag called apply C groups. Previously, this didn't work on Linux distributions using the unified C groups v2, and now it does. And this also fixes issues with the OCI commands, which require C group functionality and previously had trouble on these distributions using the v2 C groups hierarchy. So quite a bit of stuff now kind of in the master branch, contributing towards a 3.9 release. If there are any questions about any of this or any suggestions or anything, happy to try and answer any of these now, or please do reach out to us on Slack or through the mailing list and so on, and we'll be happy to talk about these and answer any questions or consider any input that people have as we move towards that release, which is scheduled for November. That's me talking a lot now. So any kind of questions on this stuff at the moment? Okay, I'll let Adam give a brief update about Sift version 2 and what that entails.
Yeah, thanks, DT. I'll just share my screen here. Yeah, so just going to go through a brief overview. I think we've talked a little bit about Sift v2 on the last call. But Sift v2, the final release of it, actually went out on Tuesday this week. So quite a few changes at the interface level, kind of at the API level. But as Dave mentioned, as a user of Singularity, and even if you're using this, in a product, the module itself, the on-disk format hasn't changed. There's full compatibility kind of backwards and forwards from version 2 to version 1. And in fact, for a period of time, I intend to maintain V1. So, there's still some projects, even at Sylabs, that are using them, but also externally using V1. So for a period of time there'll be some chance to migrate to the V2 API, and then hopefully it provides a stable footing going forward. So just to kind of go over quickly what the changes are, the majority of it, and really the impetus for this, was we were relying on a couple of now unmaintained packages or deprecated packages. The Satori Go UUID one here was actually the one used to generate unique IDs within Sift images. This is an abandoned module that actually has quite a serious security vulnerability in its most recent tagged release. So we did have a workaround that was available to use in V1, but just because of the way the semantics of semantic versioning work in Go, this was used in the external API for Sift, and so it wasn't actually possible for us to migrate to a newer, better package that is maintained without doing a major release. So that was actually what triggered kind of the major release. And then in the process of doing that release, it was discovered that the kind of official but experimental package listed here, the OpenPGP package released by the Go team, was in the process of searching for a maintainer and didn't find one. So they've actually now kind of put that package in a deprecated state. They're doing security updates on it, but they're no longer doing functionality updates. And it turns out there's some new types that have been added in PGP that make that problematic. So with newer GPG tools, you can actually generate keys that can't be parsed using the OpenPGP package, and that's not likely to be fixed, as that would be a feature release for that. So those are really the two kind of core things. And then, we just had a laundry list of stuff using Sift over the years that could be improved. So there's kind of a new functional options pattern that, if you're a Go developer, that's probably familiar to you. At a high level, though, really what that allows us to do is to add functionality as we go forward easily to the API without having to break compatibility with existing code. So hopefully, version 2, I think a lot of thought has gone into how we can make it extensible in the future for different use cases, and making it easy to extend if you want to store a Sift in some custom storage type. There's a simple interface now that needs to be implemented to do that. And in fact, I've added just a basic buffer type that's a fully in-memory Sift implementation. So if you have a need to do very quick manipulation in memory only and you want to throw it away afterwards, never store it on persistent storage, that's actually possible now with the version 2 API. And then, the only other big change is kind of the way it's built. So if anyone uses Sift tool, that's the binary that allows you to manipulate kind of at a very low level Sift images. So you can actually go in and dump out the definition file, or even the root file system itself. That's always been a separate standalone binary. That's the same commands are exposed by Singularity itself, but in a CI process or something, if you need a lighter weight alternative, Sift tool is there. I've gone ahead and made it so that the release is now fully automated for Sift, and we're actually publishing binaries for Sift tool. So I've got Darwin and Linux on a few on ARM and AMD64 right now. Really easy to add other platforms. So yeah, if anybody has a need for that or a want for that, just open an issue, be happy to add it. And the only other change under the hood really is being built with a tool called Mage. I'm a big fan of Mage, so I'll give it a bit of a shout out here. This is effectively kind of like a make or a rake replacement, but it's written in Go, pure Go. So this actually means that when we build Sift tool, the entire build chain is also versioned through Go. So the version of Go, we're using the version of every single package. It's not relying on anything on the host in terms of the shell or a make binary or anything like that. So it just makes for a really reproducible build, and works really well in CI systems. You don't have to worry about installing any dependencies or anything. It's all kind of pure Go. So yeah, that's kind of a quick overview of Sift v2. And I'll just, I think this was mentioned already, this has actually been pushed out in the 3.8.3 release that just went out. So fingers crossed, there's no major bugs. There are a lot of changes under the hood here. So certainly possible there's going to be an issue or two pop up, but I'll be watching for that closely. So yeah, that's about it. Happy to take any questions if there are any. I know I'm quite down in the weeds here with the Sift module, but all right. Well, DT, I guess I'll pass it back to you.
Thanks for that, Ad. So hopefully we've given a half decent update of what's going on over the past month development-wise. Now we've got a few minutes left, so if there are any other kind of topics or anything anyone wants to bring up, please do. Be glad to talk about it in this time. Otherwise, we will end a little bit early. Okay, I'd like to thank Heinz again for joining us and demonstrating a really awesome project, which has had a lot of work on it. We will be posting this video shortly today, so we'll definitely have more people see Hinkscala. The Americans who haven't woken up yet on the West Coast will get to watch that. Next month, we will have this meeting in the later slot. So that's in the US kind of afternoon. So we hope to see people then. Thanks for joining us, and hope you have a nice rest of your day.
Thanks, everyone. Cheers.
Thanks for having me. Bye.